All of you, good evening. Welcome to the session. Continuation of network theory, that is circuit theory concepts. I'm discussing the different concepts with respect to chapter 1, that is fundamentals of electric circuits. This is the lecture 7 on fundamentals. One more important topic with the fundamentals of electrical circuits, that is the types of network elements. We know that the network elements are broadly classified into following types. One is active and passive elements. Another one is linear and non-linear elements, bilateral and unilateral elements, distributed and lumped elements, time invariant and time varying elements. Now we have to see what exactly active elements and passive elements, linear, non-linear, bilateral, unilateral, distributed, lumped, time variant and time invariant elements. When the particular element is said to be active elements, an element is said to be active element, it is able to deliver electrical energy to external connected net. If an element is delivering the electrical energy to external connected network, then we can say that that element is the active element. But what are the examples of active elements? Sources, most of all the sources are the active elements. That is, we have to take the generator and battery is the active element. Elements that are capable of amplification is also treated as active elements. That is BZ and op amp. Elements that are capable of amplification, only particular application, not in all the application. BZT, operational amplifiers, in amplification applications only, it is treated as a active elements. That is locally, the elements are active elements. Local in the sense for particular condition, not in all the conditions, for particular condition. Particular condition here during amplification. Then BZ and op amp is also active elements. It is amplifying means it is also delivering some extra energy. That's the reason why it is treated as a active element. Then what is the passive elements? When the particular element is said to be passive element. An element is said to be passive element, it absorbs electrical energy and converted in the form of energy, and it is converted into other form of energy. Absorbs the energy and it is converted into other form of energy. Take the example of resistor, inductor, capacitor, transformer. All these are the passive elements which takes the electrical energy, converts into other form of energy. Can you accept this? If you take the resistor switch, resistor, electrical current is flowing through the resistor, it dissipates the energy in the form of heat. Inductor, whenever current is passing through the inductor, then it stores the energy in the form of magnetic field. The form of magnetic field. If you take the capacitor, whenever electrical energy is applied to the capacitor, which stores the energy in the form of electric field. Electric field. That is, it takes the energy and convert in the form of another form of energy. What about the transformer? Even transformer is also externally it is not energy conversion element, but internally it is energy conversion element. If you take transformer, in transformer, input is electrical, output is also electrical. Correct? Input is electrical, output is also electrical. But this electrical energy is converted into magnetic form. Internally there is energy conversion. Internally there is energy. That is internally transformer is a energy conversion element. Energy conversion element. How it is internally it is energy conversion element. We are giving electrical input, we are getting magnetic form. That's why it is also treated as a passive element. As a definition, this is active element definition, is the passive element definition. What are the examples? But mainly in competitive exam, with respect to VI characteristics point of view also, the questions are framing, identify the, is it an active element or passive element? In VI characteristics point of view, how to identify, is it a active element or passive element? That is, From VI characteristics point of view, if slope is positive, that is R is greater than 0, then it is treated as a passive element. If slope is negative, it is treated as a active element. In a given characteristics, both R less than 0 exist, R greater than 0 exist, then you have to take that element is the active. That is, if only positive slope is there in a given characteristics, take that is the passive element. You will see later on, I will explain some examples. Slope is negative, you have to take the active elements. In a given characteristics, both positive slope and negative slope is exist, then you have to take that is the active element. Yes, sir. This is about the from VI characteristics point of view, how to identify is it an active element or passive element? Is it active element or passive element? Then one more note that I am going to explain here. How to identify is it active element or passive element? If voltage sign and current directions are not given along with characteristics, that is for any element, if only characteristics are given, there is no any data regarding to voltage polarity and current direction, then the type of element is identified by rule of slope. By using the rule of slope only you have to identify the type of element. Slope is positive, passive element. Slope is negative, active element. In sometimes they will give the, in question framing, voltage sign and current directions is given along with characteristics. Voltage sign and current direction is given along with characteristics. And if it is indicates power absorption, given current direction indicate the power absorption, then type of element is identified by rule of slope. If current directions, voltage sign and characteristics also given, in that case also you have to identify type of element by using rule of slope. Every example I will explain. How to say that any element is power is absorbing or power is releasing. Let for any element, let this is the positive and this is the negative. If current is enter at positive, then you have to take the it is absorption. For any element, you have to take this is any element. Then power is absorbing. If the current is leaving at positive terminal, that this is the positive and this is the negative. The current is leaving at positive terminal, then power is delivering. Power is delivering. Power is absorbing means passive element. Power is delivering means active element. Power is delivering means active elements. If voltage sign and current directions is given along with characteristics and it indicate the power delivery, that whatever the current direction is there, according to that current direction, if it indicating power is delivering, then type of element is identified, not rule of slope. That is identified based on power absorption and delivery. Don't apply rule of slope here. Here only rule of slope. Here only rule of slope. But in this case, directly, is it power is absorbing or power is delivering? Power is absorbing. Then you have to take power absorbing. Power absorbing means which elements, friends? Power absorbing. Then it is a passive element. Passive element. Then power is delivering. Power delivering. Then you have to take that is the active element. Active element. Yeah, these points mainly you have to concentrate. Now, with this knowledge, the first model of questions. If voltage sign and current directions is not given along with characteristics, then the type of element is identified by rule of slope. That first statement I given. See, for example, this example one, sir. That this is the example one. If the characteristics are given like this, then identify the type of element. These are the given characteristics. Now to identify the type of elements. This is V minus V, I minus I. Then what is this type of element? Then you find the slope. Find the slope here. Slope is V by I. V by I. This is positive. Positive means R greater than 0. Find the slope here. Slope equal to minus V by minus I. That is positive. That is R greater than 0. Then what are the elements, friends? It indicates passive element. This characteristics indicates the passive element. Like this you have to identify. This characteristics indicates the passive element. For example, if characteristics are given like this, one more example. If the characteristics are given like this is V, this is minus V, this is I, this is minus I. What are the slopes? Find the slope here. What is the slope? Slope equal to v by minus I. That is the negative slope. That is r less than 0. Find the slope here. Minus v by I. That is the negative slope r less than 0. Then what the element? If the slope is negative, then this element is which one, sir? Active element. This characteristic indicates the active element. That is, simply characteristics are given. You have to identify the type of element just by finding the slope. Next, one more example. This example 3. If the characteristics are given like this is v, this is minus v, this is I, this is minus I. What the type of element? Just to find the slope. Slope equal to v by I. That is positive. Then which element? Passive element. This also passive element. Passive element. If the characteristics are given like this. Example 4. Example 4. This is v, this is minus v, this is I, this is minus I. Find the slope. What is the slope? Slope equal to, what is the slope, sir? V by minus I. That is negative slope. R less than 0. Then what is the element? Active element. Active element. Next, if the characteristics are given like this. Example 5. This is v, this is minus v, this is I, this is minus I. What is the slope? Minus v by minus I. Positive. R greater than 0. Which element? Passive element. Passive element. One more example. Example 6. If the characteristics are given like this. This is v, this is minus v, this is I, this is minus I. What is the slope? Slope is negative. Which element? Active element. Which elements are active element? Like this. That is, if the characteristics are given, you find the slope. If the slope is positive, then it is a passive element. If the slope is negative, then it is a active element. This is model 1 questions. Model 2. If voltage sign and current direction is given along with characteristics, and it indicates the power absorption, then the type of element is identified by rule of slope. The type of element is identified by rule of slope. See, for example, this is the element. This is X, that is one element. This is I, this is plus minus. Characteristics are given like this. This is V, minus V, I, minus I. That this is the characteristics. These are the characteristics. Find the slope. First, this current is entering at positive. Current is entering at positive. This element indicates the power absorption. Power absorption. Current is entering at positive. That indicates the power absorption. That indicates the power absorption. If it is a power absorption, element is identified. Rule of slope. Positive. To find the slope this side also. That is minus V by minus I. That is positive. R greater than 0. Slope is positive. Then which element is positive? Positive element. If one more example I am writing here. Characteristics are given like so. If the current direction and polarity is given like this is plus minus is the current direction. And characteristics are given like this. This is I, this is minus I, this is V, this is minus. And characteristics are given like this. This also indicates power absorption. If power absorption is indicates, then you find the slope. This is changes. If power absorption is given, this is V minus V, this is I, this is minus. Find the slope. Slope equal to V by minus I. Positive or negative? Negative. Find the slope. Slope equal to minus V by positive or negative? Negative. But I told already, friends, indicate the power absorption. It indicates the power absorption because current is entering. Point to remember, current is entering positive. That's why it's the power absorption. The power absorption, but don't take passive element. Then you apply according to characteristics. Don't use this one. Then according to characteristics, then what this one, friends? This is the active element. Slope is negative now. Don't take it as a passive element. It's active. active. Power is. But point to remember, in a long duration, some active elements is also acts as a passive elements. But passive elements not acts as active elements in long duration. See, for example, for example, inductor under transient condition. Inductor under transient condition. Inductor under transient condition, it is active element. And some elements, if you take any active elements, take the BZ2. BZ2 we are treating locally, it is a active element. But some conditions, it also acts as a passive element. That's why if both current directions and polarity and characteristics are given, if this indicating the power absorption, because current is entering at positive plate, it is indicate the power absorption. In that case, the type of element is identified not by power absorption, power delivery. You identify by rule of slope. Next, model 3. If voltage sign and current direction is given along with characteristics and it indicates the power delivered, then the type of element is identified by rule of power absorption and delivery. See, for example, if it is given like this, this is x, this is I, this is plus, this is minus, and these are the characteristics. This is V, this is minus V, this is I, this is minus. This gap. Now what this indicates? Power delivered. This indicates the power delivered. Then if it is power delivered, even though characteristics are given, according to power delivered and power absorption only how to. Power is delivered in which element? Active. Power is delivered in active. That's why it is active. Don't apply rule of slope. Don't apply rule of slope. Next. One more example. If it is given like this. This is plus, this is minus, this is I. And characteristics are given like this. This is V, minus V, minus I. Again, what this indicates? Current is leaving at positive plate now. Power delivered. Power delivered. Then what is element? Active. Don't apply rule of slope. Active. Based on the type of model, you have to solve that question. Then last model. In a given characteristics, if both r less than 0 or greater than 0 is exist, then you have to take that element is the active element. See, for example, if the characteristics are given like this is V minus V, this is I, this is minus. This side r greater than 0. Slope is r greater than 0. This side slope is r less than 0. Now what the type of element? If r greater than 0 and r less than 0 is exist, if r greater than 0 and r less than 0 exist, then this element is which element? Active element. Active element. If r greater than 0 or r less than 0 exist, then it is a active element. Active element may takes the power or delivers the power. Sometimes may also takes the power. Mostly delivers the power. But in long duration, it may takes the power also. That's why in given characteristics, both r less than 0 and r greater than 0, then it is taken as a active element. Clear, friends? These are the 4 models. Simply, how to identify active and passive elements? Slope is positive, passive element. Slope is negative, active element. Along with the characteristics, if polarity and current directions are given, if polarity and current direction is indicating the power absorption, then also you apply the rule of slope. If current direction and the polarity indicating power delivery, then don't use the rule of slope. Directly, power absorbed and power delivered, you have to identify the element. Both r greater than 0 and r less than 0 exist, then you have to take that is which element? Active element. Next. Here I given some point. BZ is globally passive, but local as amplifier it is said to be active. In some conditions only it is active. Most of the semiconductor devices, when biased with internal cutting voltages, leakage currents are said to be active. It is a biasing voltage with internal voltages, then it is active element. Inductors and capacitors globally passive. No doubt at all, it is a passive element. But locally during transients, we know that inductor release the energy, capacitor releasing the energy. During transient condition, releasing the energy. Releasing the energy means delivering the energy. That's why in local condition, local in the sense in some conditions, it is treated as a then said to be active. If it is given inductor and capacitor, answer is active and answer inductor and capacitor is passive element. If the question is asked like this, under during transient condition, inductor and capacitor acts as a, then your answer is active element. Then your answer is active element. Because inductor releasing the energy, storing and releasing, during releasing the energy, and capacitor is discharging the energy. During that case, it is treated as an active. But globally, it is a passive element. Even BZT is globally is a passive. As an amplifier, it is active. Most of the semiconductor devices with cutting voltage also active element. Like this, you have to identify the type of element, active or passive. Next, one more type of element is linear and non-linear elements. When the particular element is said to be linear element, when the particular element is said to be non-linear. Very important. An element is said to be linear whose VI characteristics follows one equation of straight line passing through horizon for all times, otherwise it isn't. That means whose VI characteristics are passing through horizon. If the characteristics are passing through horizon, then only it is a linear. And one more is throughout time, both the sides, throughout time, both the sides, one equation of straight line. For any time, it is having only one equation of straight line. It does not have the change of characteristics, only one characteristics and one equation of straight line in both the sides, and it must pass into horizon. See, for example, friends, see, is a linear or a non-linear. For example, if the characteristics are given like this, this is V, this is minus V, this is I, this is minus. Can anybody tell it is a linear element or non-linear? It is a linear element because it is passing through horizon. This side only one characteristics. This side also only one characteristics. Throughout only one straight line. The characteristics are not changing. Throughout both the sides it having only one line of one equation of straight. Then it must pass into horizon. That's why it is a linear element. It is a linear element characteristics. One more example I am writing. Yes. If the characteristics are given like this, writer. If the characteristics are given like this, then is it a linear or non-linear? This is V, this is minus V, this is I, this is minus I. It is also passing through horizon. It is also passing through horizon. And both the sides, one equation of straight line. This side also one equation of straight line. This also one equation of straight line. This also linear. This also characteristics of linear. One more example. If the characteristics are given like this. Yes, students. This is V, this is minus V, this is I, this is minus. Can anybody tell it is a linear or not? It is a linear or non-linear? Come on, respond. Anybody? Is it a linear or non-linear? Yes. It is passing through horizon, but even though it is passing through horizon, up to this one equation, after that the equation is changing. It must have only one equation of straight line. Understand? Up to this one equation, after this it is changing. Here also, up to this one equation, after this the equation is changing. That's why it is a non-linear. It must pass in through horizon and one equation of straight line only, both the direction. Then only it is a linear. Otherwise it is a non-linear. One more example. If the characteristics are given like this. Yes. This is V, this is minus V, this is I, this is minus I. It's a linear or non-linear? It's a non-linear. It is not passing through horizon like this. It is only started here, not passing. That's why it is a non-linear. One more example. If it is given like this, linear or non-linear, it is also non-linear. It is not passing through horizon. If the example is given like this. This is V, this is minus V, this is I, this is minus I. Can anybody? It is a linear or non-linear? It is also non-linear, not passing through horizon. Not passing through horizon. One more example. Yes. If the characteristics are given like this. This is V, minus V, I, minus I. It's a linear or non-linear? It's also non-linear. If characteristics are given like this. Yes, V, minus V, I, minus. It is also not passing through origin. It is a non-linear. Like this, you have to identify is it a linear or non-linear based on the characteristics. Mathematically, the elements are said to be linear. It must satisfy Ohm's law, homogeneity, and superposition principle. At this point, you know, note I am giving. Mathematically, if any characteristics are given, just you have to see is it passing through origin. On both the sides, it must have only one equation of straight line, not different equations. Then only it is a linear, otherwise it is a non. Mathematically, yes, mathematically, the element which satisfy Ohm's law, Ohm's law, homogeneity, homogeneity principle, and superposition principles, superposition principle. Then it is treated as a which element? Then it is a linear element. Otherwise, it is a non-linear element. Okay, like this, you have to identify linear and non-linear elements. Next, when the particular element is said to be bilateral elements and when the particular elements are said to be unilateral elements. Students, it's very simple. An element is said to be bilateral. It offers same impedance for both the direction of current and for both the polarity of voltage. Otherwise, it is a unilateral element. Both the direction of current and both the polarity of voltage, it offers the same impedance. Then we can say that it is a bilateral element. Otherwise, it is a unilateral element. Bilateral element has identical VI characteristics for current in both the directions. Bilateral element has the identical VI, not the one equation of straight lines. Both the direction must have identical characteristics. That is, both the direction slope must be equal or identical characteristics. Then we can say that it is a bilateral element. Otherwise, it is a unilateral element. Identical VI characteristics. That is, both the direction slope must be equal. Both the directions slope must be equal. Slope must be equal. That is, an element is said to be bilateral element. It offers the same impedance for both the directions. For example, let's consider this resistance offers a resistance of R. If the current is this direction, voltage this polar. Now I'm changing for same resistor. I'm not changing this resistor. For same resistor, I'm changing the current direction is like this, polarity is like this. For same resistor, this is the current directions, polarity. For same resistor, this is the polarity, this is the current. For this direction, it offers the R resistance. For this direction also, it offers the same resistance. Is it offers different resistance? No. That's why it is a bilateral element. Take the example of inductor source. Take the example of inductor. This is 1, this is 2. If you take the inductor, let for this current direction, the inductance offers the inductance of L or reactance is XL. You have to take the reactance is XL. For same inductor, I am changing the current direction and polarity. For same inductor, it offers same reactance only. It offers same. This direction it offers same reactance. This direction also it offers same. That's why it is a bilateral. For example, you have to take the capacitor. And this is the current direction. This is the polarity. It offers the capacitance of C or it offers the reactance of X in one direction. For same capacitor, I am changing the current direction and polarity. Then also it is a XC only. It cannot offer different because same capacitor. That's why it is which element? Bilateral element. Even inductor also bilateral element. Both the direction, it offers the same impedance or same reactance. It is also bilateral. These are the bilateral. That is, resistance, inductor, and capacitor are the bilateral elements. Take the one more example. If you take the diode in forward bias condition. This is a diode in forward bias condition. Anode is connected to positive plate, cathode is connected to negative plate. This is the polarity and this is the current. Under forward bias condition, diode acts as a closed switch, then whose forward resistance is nearly equal to 0. Now, I am changing the polarity for diode. If you change the polarity for diode, this is under reverse bias condition. Under reverse bias condition, what about diode? Diode acts as open switch or closed switch? Open switch. Diode is under reverse bias condition. It acts as open switch. Then whose resistance is infinity? Now tell the students, is it a bilateral element or unilateral element? Is it offering the same resistance in both the direction? An element is said to be bilateral, offers same impedance for both the direction of current and both the polarity of voltage. This is plus minus. I changed minus plus. Plus minus zero resistance. Minus plus infinite resistance. It is offering different resistance. That's why it is a unilateral element. Clear, sir? Understood? What exactly bilateral element? What exactly unilateral element? See, for example, this is 10 ohms. I'm using same 10 ohms, but I'm changing current direction. Here also 10 ohms, here also 10 ohms. Clear? For example, reactance is XL. Just for same element, I change only current direction and polarity. Here also XL only. But here, plus minus forward bias 0. Minus plus reverse bias infinite. Ideally, the diode under reverse bias condition, it offers the infinite resistance. Practically, it is high value. Ideally, infinite resistance. Open circuit na infinite resistance. Understand, sir? What is the bilateral element and unilateral? In general, semiconductor devices are the unilateral element. It offers different resistances if the polarity is reverse biased. It offers different resistance if the polarity is reversed. That's why these are treated as a semiconductor devices are unilateral elements. For bilateral element, the characteristics are symmetric about horizon. Bilateral elements, the characteristics are symmetric about horizon. I will give the with respect to characteristics also. For bilateral element, the slope of A characteristics for I greater than 0 and I less than 0 is same. Both the direction slope must be same. Slope must be equal. Slope must be equal. For bilateral. For unilateral element, the characteristics are not same for both the direction. The example is diode. The example is RS. If you take a RLC characteristics, if you take any RLC characteristics, yes, friends. This is I, this is minus I, this is V, this is minus V. Sorry, change the current action. This is V minus V. Take like this. This is V, this is minus V, this is I, this is minus. This is RLC characteristics. This is which element? It's a bilateral. Both the direction slope is equal. Both the direction slope is equal. It's a bilateral. This is for RLC. If you take this as diode characteristics, this is minus V, I minus. Practically, the diode characteristics are like this. The characteristics are not different in both the directions. Understand? That's why it is for diode. This slope is different, this slope is different. That's why it is a unilateral element. Unilateral element. But RLC, these characteristics are same. Both the direction slope is. But this side slope is different, this side slope is different. These characteristics are different, these characteristics are different. Unilateral element. That's why all the semiconductor devices are the unilateral element. All the semiconductor devices are unilateral element. Devices are unilateral. At this point, clear what is the bilateral and unilateral element? Yes. I'm giving an example. Can anybody answer this? If the characteristics are given like this, the characteristics are given. This is V minus V, I minus C. Is it a unilateral or bilateral? Both the sides, the characteristics are same. This side characteristics are same. That's why it is a bilateral. Both the sides you take at any point you calculate the slope. At any point you calculate the slope. Values are not given. Let us assume that symmetrical values only. Then at any side you calculate the slope is equal. Bilateral. But it is a non-linear. Linear or non-linear? Non-linear. Why it is a non-linear? Up to this one characteristics. After this characteristics are changing. That's what it is. Why it is bilateral? Both the sides same characteristics. Here same. Here same. Here same. Here same. That's why it is a bilateral. See, non-linear, linear means same equation of straight line. Characteristics will not change. Bilateral means same characteristics in both the direction. This is same, this is same. After this same. Understand? That's why it is a bilateral and a non-linear. Bilateral and a. What about this one, friends? This is I, this is V, and this is minus V. This is V, this is minus V. This is I, this is minus. What about this? Same straight line passing through horizon now. Passing through horizon. Then it is a which element? It's a bilateral and a linear also. Bilateral and linear. It's bilateral and linear. The point to remember, students, very important statement. All linear elements are bilateral, but all bilateral elements may not be linear. That is, note all linear elements are bilateral. All linear elements are bilateral. This is linear bilateral. All linear elements are bilateral. But all bilateral elements are all bilateral elements, not linear. Take this one. Even that is a bilateral, but it's a non-linear. Even that is a bilateral, but it's a non. That's why all bilateral all bilateral elements not linear, not linear. See, for example, I'm giving one more example. If the characteristics are given like this, can anybody identify? Is it a unilateral or bilateral? Can anybody identify? Is it a unilateral or bilateral? This you find the slope this side, v by. This side is slope is minus v, that is v by minus I. I told you slope is equal in both the direction. Then only it is a bilateral. That's why it is a unilateral. Slope is not equal in both the direction. That's why it is a unilateral. For example, if it is given like this, if it is given like this, this is 4, this is 5, this is 2 minus 2, this is minus 10, v minus v I. But even though these characteristics are same, but values are not given, that's why we are assuming that equal values. That is symmetrical. Slope is equal. But here values are given. You find the slope here. This direction slope is 4 by 5. What is the slope here, friends? Slope is, what is the slope? Minus 10 by 2. Slope is minus 10 by 2. Minus 10 by minus 10 by minus 2. That is 5. But here slope is 4 by 5. That is 0.8. Is the slope is equal? Both the directions. If values are given, according to given values, you find the slope in both the directions. This slope is different. This slope is different. That's why is a unilateral or bilateral? Unilateral. Sir, what I told, slope is equal. For bilateral elements, characteristics are symmetric about horizon. For bilateral, the slope is same in both the directions. For I greater than 0, I less than 0. But, sir, why you taken this is the bilateral, but why you taken this is unilateral? But here I don't know values. I'm assuming that the slope is constant at every point. That's why it is a. But here values are given. According to given values, you have to calculate the slope. That's why this slope and this slope is different. Both the direction slope is not equal. That's why it is a. Which one? That's why it is a unilateral. Here, slopes are not equal. Slopes are not equal. 5 not equal to 0.8. Like this, you have to identify. Distributed and lumped elements. When the particular element is said to be distributed element, when the particular element is said to be lumped element, distributed and lumped element. Lumped element are those in which electrical properties like R, L, C, etc. are assumed to be located on a small space or single point. That means lumped elements means you have to identify, yes, this is the resistance, this is the inductance, this is the capacitance, this is the conductance. Like that you have to identify. Then you can say that that element is the lumped element. If the elements are physically separate, you have to identify how much resistance, inductance, capacitance is there just by seeing. Yes, this is the resistance I made. This is the inductance. This is the conductance. This is the capacitance. Then it is a which elements? Lumped element. This is the lumped elements. An element can be considered as a lumped element if its length is negligible when compared to the wavelength of the electromagnetic wave propagation. If length is negligible when compared to the wavelength of the electromagnetic wave propagation. In this case, wave propagation effects may be neglected. What is the wavelength of the electromagnetic wave propagation, friends? What is the wavelength of the electromagnetic wave propagation? If you take the lambda equal to the wavelength of the electromagnetic wave propagation is V by F. The velocity of wave propagation in a overhead transmission line is light velocity. You know this one. At what velocity the electromagnetic wave propagation in a overhead lines, it's a 3 into 10 to the power of 8. Now, if you take for any frequency, for 50 Hz frequency, you take. For 50 Hz frequency, what the wavelength of electromagnetic wave propagation? 3 into 10 to the power of 8 by 50. This approximately equal to 6,000 kilometers. 6,000 kilometers. Correct? 0.6. This is 6,000 kilometers. Yes. What I told, an element can be considered as a lumped if its length is negligible when compared to the wavelength of the electromagnetic. You imagine, sir, what is the length of the inductor? What is the length of the electromagnetic wave propagation? 6,000 kilometers. but length of the inductor, capacitor, and resistor is negligible as compared to this one. That's why those elements are treated as a lumped elements. Where lambda is the electromagnetic, that is the wavelength of the electromagnetic wave propagation. That formula all of you. KCL and KVL is applicable for the lumped elements. We know that at low frequency, KCL and KVL is applicable for the lumped elements. And you take this is the pi model of medium transmission line. This is the pi model of medium transmission line. Medium transmission lines. This is the T model of medium transmission line. This is the pi model, and this is the T model of medium transmission lines. T model of medium transmission. This is for medium transmission line. This pi model and T model is the nominal model. Nominal model. Nominal model in the sense directly we can construct. There is no any assumption here. That's why it is a nominal pi model, nominal T model. Electrical, if any electrical students are there, you know this. For medium transmission line, it is a nominal pi model and nominal T model. That's why these are the examples of which one? Lumped elements. These are example of lumped elements. This representation also is a lumped elements representation. It is also lumped element representation. Even in short transmission line, lumped RL model is used. If you take the in short transmission lines, you take in short transmission lines. Note I am giving. If I take in short transmission lines, lumped RL model. Lumped RL model is, we don't use C, only lumped RL model. In short transmission line is used where capacitance is neglected in short transmission lines. It is a medium transmission line, there is a capacitor is also present. It is a pi model, it is a T model. In medium transmission line, this is the nominal values. Directly you can construct. There is no any assumption. Why it is treated as a lumped element whose length is negligible as compared to wavelength. For 50 Hz frequency, you take the length of the inductor, you take the length of the wavelength is an example. For the distributed elements. Distributed elements are those in which electrical properties RLC are distributed throughout the element. It's not physically separable. See, for example, if you take the transmission line stress, just by seeing this transmission line, just by seeing this line, can you identify, yes, this is the resistor, this is the inductor, this is the capacitor, can you touch like that? No, it is not physically separable. If you take one transmission line, we can't physically separable resistor, inductor, just by seeing that one. Then it is a distributed elements. The examples of distributed element is transmission lines. What is the example of distributed elements, friends? The transmission lines are the examples of distributed elements. The elements which are not physically separable, those elements are treated as a distributed elements. The examples is transmission lines. But if you take a, yes, this is resistance, this much of resistance is there, this much of inductor is there, this much of capacitor. If you touch this one, yes, this is R, this is L. By touching this line, by seeing this line, can you say that this much of resistor, this much of inductor like that? Because of this reason, we know that electrical students in analysis of transmission lines, steady state analysis of transmission lines, for long transmission line, it is a distributed one. That is mainly for long transmission line, it is a distributed one. Line is a distributed mode. Distributed. Okay, this is about the what exactly distributed. That there is no inductance, resistor, and values is not physically separate. Distributed elements are those in which electrical properties RLC are distributed throughout the element. Field theory approach is used for directly on distributed. This is important. I told already. For lumped only we are using KCL and KV. For distributed we are using the field theory approach. At lower frequencies, distributed elements are approximated as a lumped element. Then only you can apply KCL and KVL. KCL and KVL is applied for low frequency. We can apply for distributed if you assume that distributed is approximated as a lumped. Distributed is approximated as a lumped, then only you can apply the KCL and KVL. But that is possible only for low frequency. At higher frequencies, we can't approximate. The physical length of the element is comparable with the wavelength of the electromagnetic wave. If you take the physical length and wave, electromagnetic wave propagation for 50 Hz is 6,000 km. Take the line of length of the line. Length of the line is also in kilometers. Electromagnetic wave propagation is also in kilometers. Both are comparable. Sir, inductor length and wavelength not comparable. But transmission line length and wavelength is comparable. That is in kilometer. Even in long transmission line is also in kilometer. Greater than 160 km. It is treated as a long transmission lines. Greater than 160 km. It is treated as a long transmission lines. That is kilometer. This is also kilometers. Length of transmission line. Wavelength is also kilometers. That is comparable. That is both are not exactly equal, but it is a comparable. That's why it is a distributed. But if you see the length of the inductor, length of the capacitor, length of the resistor, can you compare with the 6,000 km? Not comparable. That's why that is the distributed element. Sorry, that is the lumped element. Resistor, inductor, capacitor is lumped element. But transmission line is distributed element whose length is comparable with wavelength. How to calculate wavelength that I told. Sir, why you taken 3 into 10 power 8? That 3 into 10 power 8 indicate the velocity of wave propagation in a line. At what velocity in the lines the electromagnetic wave is propagating. See, whenever you can switch on the supply now, power is flowing. Our assumption is power is flowing. Our current is flowing in the line. At what velocity it is flowing? It is light velocity it is flowing. This is about what exactly lumped element and distributed. Unlike the lumped elements model, it assumed non-uniform current along each branch and non-uniform voltage along each node. Okay, uh, that means if you take the any distributive element, there is a non-uniform current distribution, there is a non-uniform voltage along each node. Okay, this is what exactly lumped elements and distributed elements. Then last one is time invariant and time variant elements. The name itself it indicates that if the parameters of network elements do not vary with respect to time, they are called time invariant elements. Otherwise, they are called time variant. Practically, all the elements are time variant, but they change very slowly. In time variant elements, at different times we get different characteristics. If you draw the characteristics for time variant elements, every element is practically it is a time variant, but actually we are assuming that time invariant because it's all slowly varying. If you draw the characteristics for different elements, at different times we can get the different characteristics. At different times we can get the different characteristics. That this is at t1 time, this is at t2 time, this is at t3 time. Then it is a time invariant elements. Time invariant elements. Time invariant elements. Very hard concept. This is about what exactly time. Most of all the elements are time variant. It is a time variant, not time. It is a time variant. Time is with respect to time, the characteristics are changing now. That's why it is a time variant elements. Most of the elements are the time variant. But that slow change is negligible. That's why we are taking the time. Can anybody answer this question? The IV characteristics curve of electrical element shown in below. The nature of the element is what this element shows. I am expecting answer from you. Come on, answer this. The IV character curve of an electrical option D. Non-linear active. Very good. That is correct. See, you find the slope. This side slope is r greater than 0. This side slope is r less than 0. If r greater than 0, r less than 0, then it is active element. It is not passing through horizon. That's why it is a non-linear. Non-linear. Non-linear, it is active element. Option D is correct. Can anybody answer this question? The IV characteristics curve of an electrical element shown below and the nature of the element is dash. The IV characteristics curve of an electrical element is shown below. The nature of the element is. Come on, do it. I'm expecting answer from you. Yes. To find the slope, slope is V by R greater than 0. To find the slope, minus V by, that is R minus V by minus I, R greater than 0. Slope is positive, then it is a passive. Next. Even though it is passing through horizon, but it is not one equation of straight line. After this, the characteristics are changing. That's why it is a non-linear. Can anybody tell it is a unilateral or bilateral? It is a unilateral or bilateral? It is a unilateral. It is not a bilateral. Why? Characteristics on both the sides is not same. This characteristics, see, up to this okay. After this it is changing. Up to this okay. But after this it is not changing. It is only fixed lines. The characteristics in both the sides are not same. That's why it is a unilateral. Why it is a non-linear? It is not one equation of straight line. After this it is changing. That's why passive, non-linear, unilateral. It's a passive, non-linear. Even here I is given, V is given. Here this is minus I, this is minus V. The slope means V by you have to calculate. Can anybody? Yeah, this is the characteristics. Characteristics are missing here. So I'm drawing. These are the given characteristics. the characteristics are given like this. You have to identify the type of element. Yes, you have to identify the type of element. This is V minus V I minus. This side you find slope you find. If you find the slope here, V by minus I R less than 0. This also slope is minus V by R less than 0. That's why it is active element. R less than 0 active element. It is a bilateral. Yes, it is a bilateral. Why? This side characteristics and this side characteristics are same. That's why it is a bilateral. But it is a non-linear. Why it is a non-linear? Different characteristics. Up to this one characteristics, after this characteristics are changing. Up to this one characteristics, after this it is changing. It is a non-linear. Active, bilateral, and it is a non-linear. Active, bilateral, and a non-linear. Then which option is correct? Active, bilateral, and a non-linear. That is option D is correct. Clear? Sir, concept very simple. Linear, say active and passive, just find the slope. Three conditions I given. R less than 0, R greater than 0. Linear and non-linear must passing through horizon. Only one characteristics in both the sides. Don't change the characteristics. Both the sides, one characteristics. One equation of sight lines. I think you understand that. One equation of sight. Then it is a linear. Otherwise, it's a non-linear. Bilateral means both the sides same characteristics. Both the sides same characteristics. That is a bilateral. If characteristics are not same, then it is a or slope. Both the sides same slope value. Both the sides same slope value is equal. Slope value is equal. And otherwise, it's a unique. Like that, you have to identify the type of it. Yeah, this is one concept with respect to fundamentals of electrical. Students, any doubt? Yes. So, any doubt? Clear? I'm ending the session because I have to start new topic. Better to start tomorrow. Uh, Up to now, I discussed about with respect to fundamentals, some basic quantities that I discussed. What is the charge? What is the current? What is the current density? What is the potential? What is the potential difference? What is the electric field? Okay, like these different parameters that I given: power, energy, all these that I explained. Then RLC elements that I discussed: resistor, inductor, and capacitive elements I discussed. Different formulas that I given. Then I discussed about energy calculations, how to calculate the energy that I discussed. Then I discussed about types of elements. See, with this knowledge, whatever the previous questions are there, try to practice previous gate and AC questions. Then I discuss types of. Next, we have to enter into KCL and KVL. Types of sources. What is the independent source and dependent source? Then what is the ideal source and practical source? Types of sources. And KCL, KVL, types of sources, source transformation. Source transformation. Then after that, we go for the elements are in series. Resistors are in series and parallel. How to reduction of that. And inductors are series and parallel. Capacitors in series and parallel. Reduction of that. If any combination of elements are given, series connection and parallel connection. Then after discussing that, then we go for the nodal analysis and mesh. Nodal analysis and mesh analysis is the final concept in the fundamentals. After that, only go for the AC analysis. This is about the today's session. Thank you. I'm ending the session. Any doubt? Any doubts, friends? Okay, thank you. I'm ending the session. I will share this PPT. Please go through this. Thank you.